Hey everyone, sorry starting slightly late. I had to run from one meeting to the other. Let me get on Twitch on my laptop so I can see all the great comments that are gonna come in. I hate Twitch, okay. Phone college. All right, we are live. Cool, all right. So, who's finished all of the arm ROP challenges? No, none of you? They can't see. Two of you. Is that actually true that two of you? What? I don't know, it says only one solve right here. So it sounds like not all of you have done it. Some of you?
I've done a bunch.
Yeah, but all of them. Is a bunch all?
Well, he's the only one that's done all of them.
That's what I was asking.
Where are your solves, Adam?
I create the challenges. I do not need to solve them. That's
I'm just here you didn't solve them.
Cool. Okay, so what we're gonna do for 318G. So there were some questions about the static binary ROP. This is there's fundamentally, I think, no unintended ways of solving this. So you can solve the idea is you have all of libc statically linked into your binary. There's absolutely, I didn't even bother looking at is this solvable because it's clearly solvable. There's like so many gadgets in there and there's so many functions in libc that you can reuse. So you have like a ret to libc style thing that's absolutely totally awesome. So don't feel like as long as there's not a way to completely bypass the challenge and just get a flag, that would be the only unintended solution for this one. There's literally so many ways you could pop that challenge. And then, so what we'll do with level 31A GCC, which is now very clear that it's hard because it says it in the name. What we'll do here is I will relax. So I extended this a week, so you have another week to work on this because I thought it was actually great of like seeing these challenges that are accidentally hard. Like I didn't intend for them to be hard, but it turns out they're hard but not impossible. So you have to actually learn things by applying them, and this happens all the time when finding vulnerabilities in real stuff. Guess what? There's not somebody that conveniently puts little gadgets in for you to use. You have whatever is there. So I extended it a week so you can work on it more. The other thing I'm going to do is relax the academic integrity policy for this challenge. So feel free. I'll also let Zolotol on the Discord act as an unofficial TA, so he can drop hints and guide people as breadcrumbs through this, so that way you can we'll solve it together. And then as the outcome of this, what I'd like is for you all to discuss, once we've solved it, what's a good hint that we can put in the description to help guide people to the solution, but not necessarily give things away. I think for my own hint of talking to Zolotol, am I pronouncing that right? Zolotol? Yeah. Okay, that was just from memory. Basically, if you can pwn the static binary ROP, you can definitely pwn this. So if you think about how can I get information like I have in static, the static binary ROP, you have libc built into the binary, so you know where all the gadgets are. But if you can find out where libc is, you can also use all the stuff that's in libc. So I think from there you can start with that. Let's chat about it online. We can talk about it there. I'm confident that as a group you will find a path forward. Does that sound good? No riots they're threatening to riot on Twitch, but I can't tell if that's one of you in class. This is your secret way of voicing your opinion. No, I'm not touching the binary. It's solved. So the idea is solve it. And it doesn't have to be the one way. I'm actually, as I was talking, I think there's multiple ways of approaching it. I think the general approach that Zolotol took is one that you can apply as well. So yeah, but no, we're not relaxing anything. Cool. Okay. Okay. The next thing we're gonna do. So that hint sucks. Leaking libc is the hard part. Is it though? I don't know. People can do it. It is hard. Yeah. See. Anyways, you can figure it out. You're strong. Apes strong together. You can do it. I guarantee it. And actually, honestly, this is a pretty good simulation of what it's like, working on a team when you're trying to exploit something, right? So feel free, completely talk about hard level 318 GCC on, we'll use the applied vulnerability research channel. So you don't have to do it in the class one because there's other people online that are also struggling with this. So in the applied vulnerability research channel, all bets are off on that one. Feel free, brainstorm ideas. Let's collaboratively work towards something there. I think together you can figure it out. I am confident. Okay, that's great. And then the next thing I was going to do, what I realized, so it's taking a little bit, so to update you on where we are infrastructure wise. So I want you to be able to run and hack stuff without needing a Mac. It turns out the state of emulation and virtualization of Mac hardware on non-Mac hardware is not what I thought it was. There was some nice proof of concept GitHub repos out there that you can find, but these don't work well when you deviate from what they do. They basically have gotten a Mac OS kernel to boot up and run bash, but when you try to run anything else, that's not what they already have installed. Like, I'm sure you guys want to compile things with Clang and debug things with LLDB. It causes a kernel infinite loop, and I'm not going to debug why this is happening because that would be insane, because even if you fix that one thing, there'll be 1,000 other things. So the what's going on there? Held for aggression. What does this even mean? All right. Sorry, I don't understand Twitch moderation. So that I think we will launch on Wednesday with a thing, but it's going to require actual physical ARM, like Apple Silicon devices that we will set up in a environment that hopefully will be transparent to you, and you'll just be able to use pwn.college, and you'll get dropped into into a Mac thing when you're doing this XNU stuff. We'll see. I'll hopefully show that on Wednesday or show how close we're getting there. But in the meantime, what I realize is one of the things that would be fun is looking at popping and exploiting other targets that are more real world. So going beyond kind of what you've been doing in pwn.college, going a little bit closer towards specifically like CTF style challenges, or maybe even real world software, kind of like what real world CTF does if you've ever done that. So it is currently not, I don't think it's quite working yet, but I have a challenge that I ported from, where is it? CTF archive. From DEF CON 2018. I'm not logged in. What? Oh, man. Somebody should file a bug report. Okay. So this will be live in the AVR thing, so you won't have to find it in here. It's a prior CTF challenge, so it makes sense to live in here. So I created a challenge back in 2018 called dub, and it's let's start it and just kind of show you. Okay, so did that work? So this is basically a crazy challenge. Yeah, anyways, I'm just gonna run it. Challenge, that's not right. Oh, you may not be able to read that. Challenge run. Okay, you have to give it a URL. You actually don't have internet access, so I wouldn't put in an actual URL. And this was a challenge that we, that I created for DEF CON Quals 2018. The teams hit it over a socket, so it was a socket connection, and then after that, this is the only output that they saw. And you just get cryptic things like booting up, and it takes a while. I'll just like talk for a while. I don't want to give a ton of the fun away, but then you'll get messages where it's storing screenshots into the temp directory. So this is for you to actually know what's going on. So if we rsync, since I got that working. Oh, okay, that's some other file. Okay, so open. So you start seeing stuff like this. And I guess it's the same stuff. All right, we'll let it boot up. So what you would, in the actual challenge, because obviously I can't just drop stuff, you would get base 64 encoded things that you had to decode and then realize it was a PNG. As you look at it more and more, you will find out, let's see. Yeah, so let's see, we can dig into this a little bit. This actually feeds in a little bit of what we were going to do today. I didn't even know that. So we see the next mock operating system, next mock 3.3, information on physical memory, yada, yada, yada. Ethernet devices, checking disks. What does this look like to you all? Some kind of what? Yeah, some kind of OS is booting up and it's just outputting data, right? This is every time you run your Linux thing and it's just like starting some services. This is what takes a while. So it's going to do that. It'll give us some output. It's still booting. I should have preloaded this. Actually, I think I did. No, I just deleted all those screenshots. That was silly. Sometimes this kind of doesn't work, but I'll explain it in a second about why. Okay. This is a good reminder. Whenever you run a demo live, you should pre-cache the data so you don't have to do this and you could just like go to things instead of making up stuff. Rsync again. That's scary. That was nothing. Okay, same image. Yeah, there we go. Okay. Finally booting, waiting to log in. Yeah, cool. So then you see this. You get to the login screen. Maybe know what next step is.
Like the precursor of Mac, kind of right after required.
Yeah, so what was the story there? Do you know the story? Why is there a next?
Isn't it like Steve Jobs was part of a company called Next, who was trying to get like an educational one?
Very close. Oh no, it's not going to be able to log in. Well, this is annoying. Anyways, we can run it again in a second. But how could Steve Jobs create a company? He created Apple, right? In a garage with Steve Woz. Yeah, you got fired from Apple. Doesn't that suck? You created this company, built it from nothing in your garage, and then you get ousted and fired from the board. And so that's a whole story. You can read about it. I think there's probably movies about it too and stuff. So, damn. Okay. What it's doing now, basically, it's trying to do, this is my very stupid thing of like doing screenshot comparison, because this has to run an emulator in a virtual environment and then interact with it. So sometimes it gets stuck in a state like this where it's like waiting to see the login screen, and it clearly can, but something is slightly different than what it expects, and it just like hangs here. So anyways, we can try that again. It should take roughly about 12 or 13. We should be able to see some stuff. But anyways, okay, so yes, so the story was Steve Jobs left, created this company called Next, N-E-X-T, which created this computer called the Next Step, which was, I think, hardware and software, which included a brand new operating system. And eventually that company was bought by Apple. So Steve Jobs came back to Apple and then ran the whole thing until he didn't anymore. And what's fascinating and what we'll get into here is basically your goal is you need to pop this software through this interface. So you have to pop software that's running on the Next OS. I think it's Next. I can't remember the exact version. We'll see it in a second. And specifically, the software that it's running is the original World Wide Web browser that Tim Berners-Lee wrote in 1993 or 1994, which is the original. And I'll show you the screenshot. It's actually running. Actually, maybe I can show you source. Yeah, I can. Okay, there's definitely a PNG in here, but one of the desktop. Yeah, so what you eventually see is something like this. So you see, and you can actually like play with this and run this stuff in an emulator. It's actually really cool because you can, if you use a Mac, you can see that like the stuff that they still have there is still interaction paradigms that exist today. So there's the www app, and then you'll notice in this is /me. So before, like, because it wasn't multi-user systems, there was just /me/flag. That is your goal to get that file. And eventually, I think the other, let's see, where's the other PNG? www, ready, good, yeah. So this is the World Wide Web app that's running here. This is the where it says overview of the web. This is that's running. So your goal is to pop this World Wide Web app through just giving it a URL, and you'll be able to see how it gets through there. And to make things easier, of course, well, maybe not of course, if maybe you're not used to things being easier, there's a tar file with the exact source code. So you can read through the source code, figure out what's happening there. You can also copy everything in opt www is everything that's in there that you need to run this. So there's this is like the disk drive that's actually running the next OS that has everything on it. I can't remember what these bins are. I think these are different OS boots or something like that. And I have instructions of how you should be able to run this as a user on the desktop. The current problem is that I think so Previous is the name of this emulator, and I think Previous is having problems with the X that's running in your desktop container, but I'm trying to figure out a better way to do this so you can actually like see what's going on when you run this easier. So this will launch later tonight. I guess I didn't set that up. And then, so what we'll do is this will be a new module of like real world CTF challenges, and you'll have the whole rest of the semester to do them. So there'll just be a few to kind of, not a ton. I won't like throw 10 at you at the last minute, but the idea is like actually apply what you learn to real world stuff. The other thing I'll say, because these are CTF challenges, there are write-ups where you can go look and read exactly how to do this. I encourage you not to do that. I can't prevent you from doing that. So, use your good judgment and all that stuff, and please don't do that unless you absolutely need to, in which case, whatever, I kind of don't care. My goal is to point you at stuff to like pop and study, and that's the important part. Questions? Yeah. Nope. This is not using QEMU. It's using a custom, I don't know, I didn't write it, but this is a emulator for the next OS specifically. And I think the architecture is some Motorola something. Yeah, so you don't have any nice, it's not like QEMU, you don't have any nice stuff. You have, but I will say once you get this environment to boot, you can poke around and do stuff. See, I don't know why this didn't work either, but now I'm upset because this was working. Anyways, I'll fix it, it'll work. It worked for an entire CTF, so it definitely does work, but this was done, 6 years ago, so this stuff kind of breaks and then you have to update it. And if anybody saw the this front end code that you talked to is all Python 2 as well. So, we're living in the past. This is way in the past. Cool. Any other questions? All right. Yeah, curse of the demo in true Apple fashion. Very, very true. I swear this was working at one point. I did get screenshots. It got to the point where it was loading the world. Actually, what's very funny, does anybody know the first website? You think the web just sprung out of existence? No. .info. Yeah. So this was the first website, info.cern.ch. I mean, anybody know why the web was created? You use it every single day. You never thought, where did this come from? Just
wasn't an alternative form of like communication for the military?
no, you're thinking of the internet and the ARPANET. So the ARPANET is the internet, right? That's how packets move around, TCP/IP, all of that. But before the web, you still had what? What's not web? Yeah, mail, email, SMTP, POP, IMAP. What else? What was it? Telnet, yep. What else? How'd you move files around? FTP predates the web. Use groups, I think, but I don't really, that's way predates my time. I don't quite understand how they actually function, but people thought like BBSs and all kinds of stuff, so so the web, right? The web is like web browser plus HTML plus the concept of hyperlinks. So you can click on a document to go to the next document. These were things that were kind of in the air at the time. People were proposing this like, wow, wouldn't it be crazy if you like had a document on your computer and then that document had links to other documents and those documents had links to other documents. And what Tim Berners-Lee was a researcher who was working at CERN. So what does CERN do? Yeah, the particle accelerator. I just think of like big circle, right? So they like spin stuff around and hit things and I don't know, do stuff that whatever they do that physicists do when they hit things at high speeds. But he was there and you had this problem at CERN that you had too many people coming and leaving all the time. So you didn't know who was there or where they were. And so what he really wanted was a better directory for CERN. Like who does what kind of research and what's their phone number and office number that you can go contact them. So he created the World Wide Web browser using a next step physical machine. That's what he was developing on to create HTTP, the communication protocol of requesting a hypertext document, HTML, and like URIs and URLs and defining that whole concept. So he created that in, I believe it was like 92. Let's see, the birth of the web. 1989. Interesting. That seems a little early. But look, you can see, look at this picture. Anybody recognize this? This is like exactly what we were just looking at of this, the next cube in the upper right. You have the World Wide Web thing here. This is 100% like the same thing. Yeah, here's the, and then let's go back and then browse the first website. So this was the first website of like, because anyways, the whole reason I started talking about this is like, you think of like now, you open up a browser, where do you want it to take you? Like your home page, but the internet didn't, the internet existed, but there wasn't a web. So where do you send people? So he had to have a site, and that was this info.cern.ch. Although this version I have, for some reason, tries to talk to this cernvax.cern.ch, and it tries to connect to it every time. And if it can't get the DNS address to talk to it, it pops up a little alert dialog that you have to click OK for. So I'm trying to, anyways, the thing I was debugging is that running my own DNS server to respond and be like, this is at 127.0.0.1, just like fetch something and go away. And anyways, to make that go away. Maybe I should just figure out how to click on it, but I don't like the idea of clicking on things. It's way more brittle than typing things. So anyways, okay, that was a long diversion, but this is the history of the web.
What's the thing at the bottom, getting the code by anonymous FTP?
Yeah, you could get the code.
Get the code?
Yeah, of the www browser. So,
I see.
Yeah. So this is the exact, and the other interesting thing, as you poke around with it, you can actually browse the internet. It looks really weird because the thing doesn't recognize JavaScript, so you can see all the JavaScript. You can actually load real websites into this browser from like the early 90s. Kind of. Yeah, and the other super important thing in here is this editor part. So actually, the vision of the web was a WYSIWYG, like what you see is what you get editor. So you can not only browse websites, but also edit them through the browser and save them and serialize the HTML back to the server. That was like the original concept. Part of the problem, though, at least historically, is that this browser was so tied to Next Step because it only ran there that they didn't have enough, or there wasn't enough market share that it didn't spread. But other people used the protocols and wrote web servers and different browsers. So Mosaic was the first browser that was super popular, and then you had Netscape and all this other stuff, Internet Explorer, everything there. So, anyways, I really like this. I think this is a cool first challenge because you'll like have to read real source code to find this bug, and it's easier because you don't have to like decompile this Motorola whatever. I mean, maybe you actually will need to figure out like offsets and whatnot, but you can have the source code to read through, which is like exactly the problem we're going to. Like you have the system, you have source code, you have the binary. How do you actually try to find the bugs and vulnerabilities there? Cool. All right. And then writing like shellcode for another language is fun, and especially because this is in the 90s. So like they're like ASLR, that doesn't even make, that's not even a word yet. And like executable stack, what do you mean? All memory is readable, writable, and executable. Like this is just concepts that don't make sense. So the actual exploitation is easy. It's just like fitting this model of what you know how to do into a new system is, I think, interesting and fun. Yeah, so 93 is when it was released to the public. That's why I had 93 in there. Cool. Any other questions, historical or otherwise? All right. This still didn't work, did it? Oh, it did. Oh, look at that. So you talk long enough and eventually... Wait, what am I doing? Why am I in there multiple times? What's going on here? Okay. And let's see, 19. Yeah, so there's that alert that I was talking about. That's super annoying. But it did... No. Let's see, 13. Yeah. So it is able to start... Oh, this is the app, worldwideweb.app. And just like, so if you use a Mac, everything that you have in applications is actually called like a .app, and they're not an executable. It's a directory with a sort of specific structure. The structure is almost the same now. And does anybody do any Mac OS like user space coding, like code apps or something? Everybody's shaking their head. I guess that's why you're taking this class. Anyways, almost all of the, not internal, but like the system level stuff begins with capital NS. And that stands for next step. So like there's NS string is like I think it's like Coca or whatever, their Objective-C, like all of their frameworks start with, and almost everything starts with NS because it comes all the way from next step, and they've like carried that all the way through. So you can see things like that. Huh? Kind of, yeah. Yeah, exactly. Like kind of like the NT kernel, but basically, but the crazy thing for me is it came from this other company that they acquired, and then like they threw out their operating system that they had at the time and like used this. Cool. Okay, so I think this will be really fun, and yeah, and there's also an exit hatch if you get stuck. Okay. So enough about, yeah, this does not work yet, but it will eventually. Okay. So enough about this. What time is it? 5. All right, let me set a timer. Set a timer for 25 minutes, please. Okay. 25. All right. Now we're going to do is turn our attention to the operating system. So I talked a lot last week about how to approach a target, right? Or how to even select a target. So the first step of approaching a target. Now that we've chosen a target, we want to do reconnaissance on that target. Why is reconnaissance important? To understand attack vectors, which is why is that important? Say it again? Yeah, I would say that how do you know? It's more about vulnerabilities, right? So how can I influence the application by knowing what input I can feed in and what are the attack vectors, right? So understanding the system, super important. So we're gonna dig in today, and I have some fun ideas planned. We're gonna read a lot of source code and dig in through this beast. So okay, I guess before I start, I meant to contact some of my friends who work at Apple. I don't actually know how to pronounce. I don't know if it's like XNU. I don't think anyone does that, but I always say XNU. But I don't know how people pronounce this, so I apologize in advance if you learned something from me that people are like, "What an idiot! Why would you say things like that?" So XNU, it stands for X is not Unix, like a classic old school acronym, and it is, like we said, originally developed for Next Step. So this is what's really cool. You're going to be popping a user space application for the next Step OS. Well, that would be a fun follow-on challenge. So pop a kernel, find some bug in the kernel, and pop that. That could be a cool challenge. All right. So this ties in really nicely. Like we said that. So the stuff that you are seeing, you will see how it's been carried for. XNU is also the kernel. There's this very confusing thing that like the operating system is called Darwin in Mac land, but the kernel is XNU, and the kernel is also used on almost all Apple stuff. So Macs, iPhones, tablets, probably HomePods too, I would assume, and every device that I think is slightly smart. I don't know about the like headphones and stuff because they have something on there. There's some chip in there, the H something, that I don't know exactly what's in there. There's also the other crazy thing. Anybody who actually has a Mac? First question. 2? I see 2 in this room. Is there any more? You're all like Linux people or Windows people? Wow. Okay. That'll make my next thing sad. But anyways, let me grab it. This guy, $90 dongle, USB-C to power, HDMI, and USB-A adapter. I bought this for the thing because this was before they had the HDMI adapters built in, which is a very nice feature. But before you had that, you had to have a dongle like this. I plugged it in, and the computer said, "Do you want to update the firmware of your dongle?" And of course, as a security person, I said yes. But then my second thought as a security person is, why in the world is there software running on this device? So there's something running on here that maybe you can hack. I have absolutely no idea, but that would be a very interesting attack surface of like popping the dongle through either HDMI input or USB input or something like that. I assume it's got to be very simple. Like, they cannot be that complicated of like, it's just got to shunt things around. But like, if you have to update it, there must have been some bug that they needed to fix. Hopefully it was not a security bug, but I have no idea. But anyways, that would be super cool if anybody could do that.
There's like a USB controller.
Maybe, but it should just pass through, right? Because like, you have USB. I have, okay, so let's look.
Apple probably has some fun little pin they can.
Yeah, but like,
It's like bus switching, right? Because you can have all things plugged in.
like, yeah, here's like a USB-A to USB-C adapter. Like, I would be shocked if there's like complex software running on here that needs updates, or that there was even anywhere to update whatever's on here. It's like a $5 thing, like throw it away, I guess. Anyways, also the displays. So the like Mac Studio and the other Apple displays, like when you plug them in, you can also update the firmware, like the stuff that's running on there. I don't know if that's a pared down version of XNU, but basically they've shown that like almost every device they use has XNU as the kernel, which is pretty cool. It was initially released in 1996, which is kind of cool. It's very, very old. The other crazy thing is it was open source in 2000, and I think I lied a little bit at the beginning of the class of why it's open source. I thought it was because it came from, they, as we'll see, used BSD stuff and this other mock kernel, but I don't think those were copyleft operating systems. They could have just completely used them and never done anything. But apparently there's this Apple public source license that they license everything under, and Well, that's not my password. That'd be a weird password. And it is I'm not a lawyer, so please, for the love of God, don't like take anything I say to court or whatever. But this is a verified open source license. I don't know the differences between this and other licenses, but it's kind of crazy that they just decided to open source their kernel. Some theories that I read people hypothesize is that like at the time they had such little market share that was a way. Plus they were replacing their old OS kernel with this new XNU stuff from Next Step, and so they wanted to try to convince people that it was more reliable because they could go read the source. Maybe it was like a marketing ploy because then you wouldn't be tied into their stuff and you could just like take it. I have absolutely no idea, but yeah, it's pretty crazy that they still do this, because I guess at any point they could just not do this and they would be fine and they wouldn't be filing any licenses. I don't know. It's crazy. Okay. Cool. So XNU is crazy, and I think I mentioned this before. It is a amalgamation of various components and parts kind of glued together over the years and grown very organically. I think that's natural of any operating system, right? They have to evolve over time. You don't just like sit down and design it from scratch. But it is we think of as like a hybrid kernel with a split personality, meaning there are two different worlds. There's the BSD world. So there's a kernel that they basically took from a BSD 4.3, which actually, I think I already have an idea of the next real world thing is going to be software that runs on BSD 4.3, which is actually, again, another great connection to what we're doing and looking at history. So this was released in 1986, kind of giving you a timeline of where we are. A lot of things in BSD ended up in current kernels, especially like the TCP/IP stack. This was one of the first major implementations of a TCP/IP stack that then got used because BSD has a very permissive license. People just yanked it and used it in their OS kernels. And the interesting thing is, so they started with this 4.3 BSD, and BSD kind of kept evolving, right? But they, as we'll see, because they had this like Frankenstein monster, this other part, they modified things, but they kind of kept up and shared code with FreeBSD. So as FreeBSD evolved, Apple would take some patches from FreeBSD, and they would also ship patches back to and upstream them to FreeBSD from XNU. I don't know. I think that's kind of interesting to look at, like this like weird co-evolution here. Actually, the fun fact is during my sabbatical, one of the bugs I found was the oldest bug because it dated back to, I think, either 4.3 like BSD kernel. I was able to trace that bug was actually still present here, but I guess I shouldn't say this because it says how old I am, but it's still not older than me. I wanted to find a bug that was older than I was, and that was not it. It was very close though. The other side is a mock kernel. So the mock kernel was, again, created around the same time, 1985. You can kind of see, especially if you read papers from this area or look at the research that's been done, you can kind of see that there was like this explosion of different like operating system ideas of like, oh no, this is how we should do a kernel, or this is how we should do a kernel. When was Linux released? My Linux heads. You do this stuff all the time. You don't know when history is important. You're just making stuff up. Can somebody look? 79?
It's like the radio.
The radio was in the 30s. Oh my God, what? 91? Thank you. Yes, 91. That makes sense because they had FTP and stuff and the internet. Like it can't have. Anyways, whew, okay. Around this time, so like in a similar time frame, right? Late 80s, early 90s. There's a lot of exploration and experimentation in this stuff. And the cool thing was the mock kernel was developed at CMU, so it was a research project. This actually is, I can't remember who did it, but one of the Project Zero people, it was probably, I don't know if it was Brandon while he was there, Brandon Azad or Ian Beer, or maybe it was Ned, but they wrote a Project Zero blog post about exploiting bugs in the memory mapping and allocation in modern day XNU. And to understand the allocator, they went back to papers that were published in like the late 80s, early 90s about mock. because it still has those features today. And so it actually helped him understand that system by reading these super old papers. This is also why history is important. You should know when things came from and how old they are. Are they 100 years old or 30 years old? 34, 35, 36? 33? Okay. I was going the wrong direction. And initially, so the mock kernel, and this was a big fight, just like I hoped people would argue about the RISC versus CISC debate in the 90s. Similar debates in operating system kernels were monolithic kernels versus microkernels. So what's the difference? Somebody tell me. Yeah, so the idea is like monolithic kernel, big kernel, lots of stuff, like everything's in, you can think of it as one address space. The real downside is basically one failure mode. So any seg fault or something in any kernel code, the entire kernel crashes. Also from a vulnerability perspective, right? You pop the kernel, you own everything, and it doesn't, nothing else matters. However, with a microkernel design, the idea was separate the functionality of the kernel into little pieces, and that way an individual piece could crash, and that would be fine. The rest of the operating system would still survive and go on. I guess you have to restart that that part, and that's why you have all these debates over like, is that actually useful? But then you have this mechanism of like, okay, but you need to talk to other things, and so how do you do that in an efficient manner? Like in a monolithic kernel, how would you call functionality from another component? Yeah, just a function call, right? You just call and then boom, you're there, get the code back. You can call any function anywhere in the kernel. It's great. But you can have problems, and that can cause massive problems. So that's where mock came from, was this idea of how do we design a microkernel with message passing, and the message passing is very efficient, because that's the downside if you have message passing components. What's it like? The cool thing is, so which design won out in the operating system wars? Yeah, Linux is monolithic, Windows is monolithic, XNU is actually monolithic, even though it has this stuff that like, it's kind of microkernel. And you can actually see the trend of like a lot of operating systems are trying to move more stuff into user space, or like reduce the need for companies or users to write kernel extensions, because that gets now part of this is exactly the CloudStrike problem, if anybody remembers, right? There's a kernel extension that had a bug that blue screened the computer like on every boot. Whereas if they had APIs of doing what they wanted, that user space processor could crash and the rest of the kernel would be fine. So you can see that. So monolithic kernels won out probably at the time, I would say, due to performance. Nobody wants to take a 10%, 20% performance hit on stuff. You're just like, hey, your kernel crashed, like fix your stupid kernel bug, which is what they did over the years and became more resilient. But this idea wasn't dead. And this is what I think is super important of looking at these things historically, of being like, well, they did all this research into microkernels. Like, was this wasted? The idea is no. So what's a modern piece of software that I guarantee you, 80% of this room uses every day that has a microkernel-like design? Yeah, what browser? Chrome. Yes, Chrome, for security reasons, has a ton of different sandboxes. You have the render, and they created a model where they separated each thing into a different process, right? Just like a microkernel has separate components running in isolated spaces. Chrome used different processes to do that same isolation, but they need a mechanism to talk to each other. So they had to create mechanisms to do this. And so you could see that as like those ideas are the evolution of the microkernel design philosophy influencing modern day software that you use all the time. And I highlighted message passing because this will, technology gods willing, that this will be our first thing that we'll actually get to play with the message passing part of mock and be able to use it to talk to use it to really understand the IPC design there. This is kind of a weird thing that I only include here. So they initially took this like version 2.5 of mock for the original XNU with Next Step. Then when they merged it in, there's apparently this open source foundation mock kernel, OSFMK. The only reason why I'm talking about this is because this is the directory you are looking for when you're looking for mock stuff. And I always forget that. And I always never remember what the heck this thing means. And I just like create acronyms in my head of like something make is always what I think of because of the MK, but it's not. It's the mock kernel. So yeah, which includes parts of like Mach 3 and some forks and all of their stuff. Anyways, it kind of was a conglomeration of everything. So just like every operating system, this is taken from Wikipedia, so I apologize for the very terrible graphic that I didn't create. So I guess it's either my fault or not my fault, depending on how you look at it. So like every kernel, there is a differentiation between user mode and user space and the kernel itself. I mean, simple question, why do we have that differentiation?
For like task isolation.
For task, what's a task?
Any like user space application.
Yeah, so every like the operating system, like the goal of the operating system in the kernel, right, is to make sure that user space programs can do whatever they need to do without harming each other and dealing with access to hardware and everything. Because I mean, back in the DOS days, if I remember correctly, each application just used whatever memory it needed and had full access to everything. And so like you just couldn't run two applications at once. Like this is like, I don't know, maybe to people that think that radio was invented in the 70s, it may seem like a shock that a big evolution was running two programs at once instead of just one.
The telegraph.
Yeah, the telegraph. I'm not gonna get into this. This is too much of a setup. Yeah. But you know the telegraph. Do you know Morse code? Yeah, there you go. Cool. I mean, you know what it is. I don't know actual Morse code. That's pretty cool. But anyways, so you want this, the idea was, hey, let, different implementations, but let each user space process like have access to what it thinks is all of the memory that it needs. But the operating system manages this lie so that two different processes can each access what they think is this exact same memory, but they never touch and never see anything. So the job of the kernel is to support this. So this is why what we're absolutely not focusing on in this class is any like how to write a Mac app, how to write an iPhone app, how to write any kind of app that runs on this operating system, because fundamentally we don't care about all of this. The only thing we care about is how to talk to the operating system, right? And that's through, just like on most things, it's through a system call. So we call into the operating system because that is the interface between user space and kernel where the process can say, do something for me. Right? And then like Justin was saying, so on the kernel side, the kernel needs to manage all these different things. The kernel also has its own stuff that it's doing. So it thinks about it in the form of a task. So you have different tasks that are doing different things. They get, I don't know, have you guys taken like operating systems? So you know about like preempting and like sharing resources and stuff, right? To make sure you don't deadlock, all this cool stuff. But like I said, this Frankenstein thing, rather than just saying, well, this is beautiful, like Linux, you could just say like Linux is the kernel. And it has different components, but it just has one box, like Linux syscalls. When you look at the thing, right, you can see all the syscalls. Here, the BSD system calls and the mock system calls are completely different. And the way to think about it is it's not like a, what is it called? Like first among equals, or like where they're actually like at the same level. Like one has to subsume the other, which is the mock kernel is kind of like the real core. So because in like BSD, just like Linux, you have the concept of like a task, or I can't remember if they call it a thread or something, but that just calls into the mock part to be like, what's the current thread, and like passes it back. So it doesn't keep, because if you think about it, this makes sense, right? You don't want to keep two different notions of like, what is a process in two different places in your operating system kernel, because if you ever get them desynced, you'll have absolute like calamity. So the source of truth is the mock kernel. It mainly handles like IPC, like we talked about, and we're going to get into next week of communication there. Also does all the virtual memory, so this is why it's a super important part. Protected memory, scheduling, preempting, I guess console IO. Whereas the BSD side does a lot more stuff that you're familiar with, like file systems, networking. The whole TCP/IP stack is in here. BSD sockets, libraries, POSIX stuff. I don't know, anything in there. So questions on this? Yeah. Say it louder. Yeah. So you will find out next week. I don't want to give it away. I mean, we'll get into it, but there actually are. What's interesting is there are fundamental differences in what types of IPC they allow. So there's things that you can do with port. I think it's mock ports is what they're called. Essentially, the core difference, which is they are unidirectional, not bidirectional. So you can have a port that only allows you to send or only allows you to receive, and so you can do interesting things with that you can't necessarily do with sockets. I don't know if there's like a practical difference, but it's interesting. And you can also, it has the concepts of privileges to it, and also the ability, because the operating system controls all the ports, so you can share that port and delegate it to another process, and now it has those same rights that you had. You can also give somebody a port with a right that says don't allow them to pass it on to anyone else. So this is how this is actually like these ports, and this concept is how the operating system allows you to do debugging and get super privileged access to things. So it actually, I mean, I don't know, why am I talking about this now? We'll talk about this next week. Anyways, okay. Other questions about this? Sorry.
Is there like a stable syscall interface on it?
What do you mean by stable?
Like, is it like Windows where it's just like changing every version, or is it like Linux where there's syscall numbers that
Great question. Our goal today is we're going to walk through and figure out exactly what happens on a syscall. But that won't answer your question of if it's stable or not until you diff it over multiple versions. It's stable-ish. I think like it is because, so I think the way to think about those things, right, is on Windows, you're not really supposed to directly, like a user space app is not supposed to call a system call. Right, there's what's the library, Win32 DLL or Win64 DLL. There's a user space DLL that on Windows you are supposed to call this DLL or NT32 DLL. What is it? Yeah, kernel 32 DLL or whatever it is. Anyways, there's a DLL, which is a user space library that you call. It's basically like a libc for the kernel. Like you call into there, and then it translates whatever you're doing into a system call that the kernel does, and then sends it back, and that translates it back. So this way, as long as Microsoft knows that all the user space apps that they're not going to break compatibility go through there, they can do all kinds of crazy, clever stuff in there to deal with different OS versions, and the OS can change. Whereas like on Linux, the boundary is on the system call layer. So if you want to be able to run an app always from an old version of Linux to a new version, the system call numbers have to remain constant. So Apple is much more in that camp, I would say, where they the interface is between the user space app and the system call interface is the AVI. But the caveat and the ish is that unlike Windows, which prides itself on being able to take an app from Windows 95, have you guys heard the stories about Windows where like there are literal shims in either the operating system or this DLL that say if your application is SimCity, then and it's targeting Windows 95, then do this behavior that it's expecting, but that's wrong and incorrect behavior because they tried to take the operating system, they upgraded the operating system, realized that the app fails, and they would add in app-specific shims in the OS to support those applications. So Windows has prided themselves on this backwards compatibility. Apple does not have that at all. So there's absolutely no guarantee that your app that worked on this thing will work on the next thing. They'll just be like, yeah, you're just going to have to recompile it, like tough. So that I think they don't force themselves into having that compatibility. but it's pretty stable, I think. And maybe we can look at like the Git history and see how often it changes. I think not very often. Cool. All right. With that, it's 5:30. Let's take a 5-minute break, and then we'll get back to it. And then we'll read the source. All right. All right, Twitch, we're taking a break. Go turn on the TV and watch an ad or something. Okay, we're about to come back. We're just testing that these changes worked. I'm feeling pretty confident about it. The audience is not. They're booing and they were hissing when the audio was off, and so hopefully we can prove them incorrect with this. I don't want to wait like 5 minutes. Okay. This is the other thing. So this does take a long time. So yanking the files to your local machine and getting it to run locally you'll be much better. And you should be able to. This previous emulator is also open source, so you should be able to compile it on your own system and get it to run. Since you all run Linux, this should be very easy because it just needs an X server to run. Okay. This actually gets to a good point of any kind of thing when doing development or vulnerability analysis or exploitation. The shorter you can make your test, like make a change, test it, loop, the happier you will be as a person. Sitting here waiting for this stupid thing to just do this like can drive you crazy. So have other ways of doing it, I would recommend. Okay, so as this is going, we can go back and start talking about the source. So since they have source, we should use it. We should not be silly and not use it. That would be not cool. So, oh no, why would you go there? Oh, well, because you're. So once I find it. Okay, so you can actually go. Apple has a whole open source Apple thing. You can see all the open source stuff. There are stuff that we are absolutely not going to talk about. Why aren't we going to talk about Swift?
It's awful.
That may not be true. I don't know. I've heard good things. Yeah, Swift is for making user mode programs. And Swift, if you make a user mode program in Swift, it has to talk to the kernel, and eventually we'll need to make a syscall. And so you can all do that in C. You don't need Swift to do any of that. I don't know. I guess if somebody's really crazy, they can write their exploits in Swift, but I would absolutely not recommend it. You should be doing your stuff in C when you're talking to the kernel. They also do Kubernetes. They also create WebKit. So WebKit is an open source, I believe it's like the content engine of like parsing HTML and doing all this stuff. So you can actually, which is used in a ton of places. Like WebKit is actually used in a lot of browsing engines. And so you can kind of see this cool, like almost cycle of life, right? Where like Next, XNU was on Next, and that created the web. And then eventually the people that made that created WebKit, this open browser engine, and then gave it back. So I think that's kind of cool. There's a lot of projects that they have that are open source. I don't know what this is. Foundation DB, MLX, CareKit, ResearchKit. Hey, maybe some of you all need this. Medical research. Okay. Password manager research is interesting. Interesting that they participate in. So they're big in LLVM and Clang. Clang is the default compiler that they use. Anyways, so what are all the C? Okay, so that's everything that's on there. If you wanted to poke around it, they used to just distribute like tarballs. So there would just be a massive list with all of these tarballs of their source releases. Ironically, they now have everything on GitHub. And the reason I say ironically is because GitHub is owned by Microsoft. So the fact that the company that they were fighting for so long, now they rely on them for distributing their own code is very bizarre to me. And so you can see, you can get very lost in here. I mean, you can poke around all you want, but there's like 509 repositories in here. The pinned repositories are probably where you all want to start. I was actually talking with some people here. I don't know when this was last updated, but yeah, 3 years ago. Apple did sell like an OS X server, so like a server version of their whole operating system. I don't think anyone uses this. This is like a super out of date thing, and I don't even think they support it or sell it now or anything. But you can find Mac OS, the iOS, and I don't know what this developers tools thing is. And clicking on here are they're basically using Git submodules in order to point to other commits, right, in the other repositories. And the other tricky thing here is you'd see like, oh, main, yes, macOS 14.0, great, this is where we absolutely are. I don't know that that's the latest. You have to either go to branches or tags. Tags is so tags is a better thing. You can see they actually just pushed a release 3 weeks ago for macOS 14.6, which actually is a pretty good. Let's see. This was in July, so July, August, September. Yeah, 2-month gap before releasing it. It's pretty good. But the other thing you'll notice is, so you want to use the tags. The tags are absolutely how they do all this thing. And then, wait, no, I don't want the commit. I want to, there we go, browse the tag. So they have a bunch of directories in here. Each of these is its own project that's basically now pinned to that version that works with that distribution of the entire operating system. So for this purposes, we'll call like operating system kind of everything, all this junk, and then we'll talk about X and U as like the kernel that we'll actually focus on. So I have absolutely no idea what all this stuff is. Some of the stuff I kind of have a rough idea, but other stuff I don't. Some of it is user space things like, oh, was there libc? Yeah, their libc is open source that you can just go check out. That runs in user space that the user space programs use. I bet you could find in there one of the big things they did within the last year was user space. The user space allocator always zeros pages, like not pages, but zeros memory on a free. So to reduce the chances of a use after free or other weird stuff, it just like every time you free memory, it gets zeroed. And so I thought that's pretty interesting. I bet that logic is in there. WebKit, like we said, so the version of WebKit, Apache, this is kind of weird that they do this, but things like Bash, even like, I know some of you know, well, I guess Fake Adam that was here the first day loves Bash, and so maybe you can troll him by finding subtle differences that Apple has made in this version of Bash, which is the version that they ship, that maybe makes some of the Linux Luminarium problems even crazier or not as useful. So there's a lot of like user space apps and a bunch of junk in here. Curl, file, anyways. So you can explore this to your heart's content. Libraries, a ton of libraries. libxml2, this is one if you wanted to look for bugs. This would be a great place to look for it in an XML parser. People have found cool bugs in there. Let's see. Python, even the Python version that they ship is, I actually don't know if it's customized or they've forked it completely. I've never done like a diff to see what's what. Ruby, rsync. And then I'm just naming things. Vim, if you like Vim. And then all the way at the bottom, you have XNU. So this is where the heart of everything is. You go in here. And now this is and this should be tagged. Yeah, so what's this? 14. Wow. So the other super annoying thing is that there's different version numbers. So there's some chart. I think it's in here. Yeah. So there's like, see, HomePod software. Huh. So they anyway, so there's versions that you may be used to thinking about, like your Mac OS version. Like, let's see, this Mac is probably, running Sonoma, which is 14.6.1. Important thing here is that this other thing is like a unique hash or part of a unique identifier that identifies usually this specific, I think it goes back to the kernel. And your iPhone, so you have iOS, I don't know, what version is it on, 16, 17, 18, something, a version number, but then you have that, you have Darwin numbers. Darwin has different numbers, which is like the whole thing. And then you have the actual XNU numbers, which is what we looked at in here. Like these are all different XNU numbers. I don't know exactly what they mean or how to parse them. You can think of them just as opaque. But you should always be able to do, not here. Wait, did it not work? sorry, we have to check if it works. This is critical. Where's my thing?
You have to exit twice really fast.
That seems bad.
No, but that second exit went to the same time.
I know. Okay. I don't care that much, but I mean, except for the fact that this is insane. I am control B. That's how I exit. All right. Okay. What? Can't.
Yeah, it's missing a P.
It's supposed to do. Where's this stupid thing? Oh, searching for open was a bad idea. OR wide web dot app. Yeah. The keystroke missed there. Oh, that's so annoying. Well, all right. I'll figure out what I can do to make this run better.
Can you write it to a script and execute the script?
You still need to type in stuff to execute it is the problem. The other thing is this is all super brittle because it was written a long time ago, and the more I mess with it, the more I'm likely to just absolutely mess things up. Okay, let's go back. Version numbers, great. You can see, yeah, anyways. All the stuff in here, oh, that's why I was getting to a terminal, so I could show you terminal, and I could show you, yeah, so in the uname, you can see the Darwin version, 23.6, and then you can see the XNU version, and then it's the release kernel on ARM64. This last one is like the machine, like specific to, because if you think about it, so there's like release, there's ARM64, that could apply to a Mac, or it could apply to an iPhone or something. So there's different targets in here of what actual specific machine to target. And I'm not sure what this part is. So anyways, this is how you can figure out where you are. And then if we wanted to find this exact kernel version, we'd look at like, this is actually probably it. No, because this is .2, so it hasn't been open sourced yet. This is probably something that's slightly, I think if, let's see, if we looked at about this Mac, what did we say? It was 14.6.1, and this I would guess is 14.6. Yeah, which makes sense. That's how we got here, right? Through the distribution link of Mac OS, 14.6. This is 14. I'm running 14.6.1, which is not open source yet. If you really spend a lot of time doing this, you will be live and die by these like releases because you want to see if they're killing one of your bugs or not killing your bugs. But sometimes they release them, sometimes they don't. Sometimes the person doing it forgets and just doesn't do it. Like I don't know what their internal criteria is. So good luck. Okay. Cool. And theoretically, I guess you can pull down all of that entire distribution. I think I've tried that once, but it takes up like a ton of room of like all those different directories. So we have that directory. And so now we will start exploring that directory. We were in here, 14.1. Let's browse there. So you would think, well, this is great. Just like any good software system, there's a how to build. Have any of you taken software from GitHub and you followed the README and tried to build it? What would you say your success rate is? What was it, 15? I think that's pretty good, yeah. Like maybe 50-ish%. All depends on how important the thing is that you're targeting. And so similar things apply here. So maybe they're late for their test next door. What are you doing? Stop going into here. So that's why people write, especially when there was the change from Intel to Apple Silicon. I'll talk about this a little bit, but there are people that write entire blog posts of how to actually compile the kernel because it doesn't always cleanly just build. And you have to install, so Xcode is the development environment. 5% online that they said their thing does. So you have to install the right version. You have to download a kernel development kit if you're building on Apple Silicon Macs, or sorry, if you're building an ARM target. The kernel development kit. What was it? Oh, you guys want to see stuff? Wow. You don't just trust me when I say things? Okay. So anyways, this is a giant blog post. It's all about how to actually build this version of 11.2. And then when version 12 came out, this did not work anymore. And I know because I've tried to build 12, and I have a way of doing it, but I'll share with you in a second. Yeah, you should be able to. I still don't 100% know, and if somebody can verify this for me, there's an Apple developer website, which is what we're looking at here. Where's my phone? Oh, this security is too secure. Okay. Where's my two-factor? Oh, because I don't have one. Yeah, that's right. Sorry, this is a different account than the one I use. I actually don't have any Apple devices, in case you can't see. Okay. Cool. I guess nobody can actually do anything with this. This is the beauty of one-time passwords. Trust, but it doesn't matter. It's private browsing. Okay. So I think theoretically you should be able to create an Apple developer account without paying, because you can pay to like launch apps on the App Store. You have to pay like $100 with a developer account. I think you can just create a development account and then, yeah. So this is where all the kernel debug kits are. This is a big, I think it's like a 12 gig download that has the release kernel, a development kernel, and a KSAN kernel. So KSAN is like user space ASAN, but in the kernel it can detect use after freeze, writing out of bounds writes, these kinds of things. And so what you need to do is find the exact, so this is that hash that I was talking about here. That's like what you need to find to get your version. We're definitely not going to find ours here, but we can at least look. Oh, it is. Okay. Yeah, so I have the 14.6.1 build. It also has symbols in here, and there's LLDB macros that help with debugging the kernel. It's actually really cool. The output, I think, in some cases can be even better than GDB, but to build the stuff, you have to have that on your machine and installed to actually do it. All on the target machines, when you need it, I think this will already be installed, so it shouldn't be an issue and you won't have to think about it, hopefully, but we'll see. Okay, yeah, so KDK package, you need to install it, yada, yada, yada. The version number needs to be right. It's also insane. There are sometimes different builds for the exact same version number, and sometimes you'll get into situations where you will have the source version of a 12 point whatever, but not the KDK version, so you can't even build it because it doesn't have the right things. I think there's something in here that they link to for ARM that's part of the boot process that is not open source, and that's what it needs for the ARM part, but I haven't dug into it a ton. So, yeah, this is, I guess, I can't make this an assignment because this doesn't make sense because not all of you have Apple devices. But one of the things I did as part of preparing for this class is try to get build scripts working for different versions. So I have one for 11.2. So these are make files. You just run make and it builds the whole thing for you. Let's test it out. Which one do we want to build? 11.2 or 12.5? 12.5. 12.5, just because the number's higher?
Yeah.
Okay. 12.5. And you can see these patches. So I had to patch. This one wasn't the OS so much as like the build environment needed to be patched. Oh, wait. I didn't read the README. This requires this SDK, the KDK, which I already have installed. So I will do it like this. We pass it as environment variable. So I've obviously already set up all that stuff, but it has to like, there's pre-stuff that it needs to compile to build tools that then it uses while building the kernel, and it uses those tools. And like the code, I don't know if the kernel, but the code in the repo like hard codes them to specific directories. So I patch them so that they look at this local bin folder that gets created. So anyways, my ask is, what would be great is if this is an open source thing, like it's public and we're just building open source stuff. So if you all who have access to a Mac, if you want to expand this by adding new versions, I think the community would really benefit because yeah, basically this last blog post was one of the latest ones that I saw of like, here's how to compile this thing. And I'm like, great, we have a script for 11. It should be easy of 12. And 12.5, let's see, what was that? This was 12.5 was, yeah, July 20th, 2022. So this is the one I'm targeting for the physical devices because I know I can build it and I know I have the KDK for it, and I think I can, that will work, and we can just study that. So anyways, I think it'd be cool. Oh no. What? Oh, I must have some other diffs that I didn't actually do. How do I diff two directories? Maybe no? Like this? Git diff -r?
I'll believe it.
Nah, I don't think that's right. It's like this, NAUR, right? Yeah. No. 12.5. Ah, see? I have uncommitted changes that I need to patch. Oh yeah, this was an insane bug where somehow, I think it's because we're using a newer compiler and null is macroed to something else that's not, I think, to 0, but this function returns booleans, and so it has to return false or true. And I don't know if this ever compiled. This like doesn't make sense that this compiled, but anyways, yes, I do recall doing this, but okay. So this is a good thing. I need to fix this because this doesn't work. So thanks for making me demo the one that doesn't work. Random student in the audience.
That was the goal.
Yeah. Cool. Okay. So anyways, I think that'd be a cool outcome of this course if we can help the community. I will say if anybody tries the latest versions, like 14, I absolutely cannot get them to compile because as we'll learn next week, there's the raw message passing IPC, but then Apple has built another layer on top of that where they define messages to call to other, like basically like an interprocedure language that you can define interfaces, and that way you can automatically compile code from there for the server and the client to do that communication and parsing and everything. And they created some new format, and that's like not in the version of Clang that I'm using. And I don't know where this is. It's like using some option of Clang to compile these. I think they're like MIG2 or MIG-Mach2. Anyways, I got into this thing, but if we can solve that problem, that'd be great. And there are like a lot of people that would be very thankful that we can solve these things. So I think it'd be a fun project to extend this out, and it'd help you get familiar with it. Because honestly, when you're doing this real world stuff, especially on, like we said, 5% of things actually compile, but you still got to find bugs in them. So like get it to compile. Like that's like the first step of this stuff is actually getting it to compile. And so you know, you can't just be like, well, it doesn't work. Like, I don't know, patch it, fix it, find the dependencies. Like, there was, oh yeah, the latest ones are missing header files that exist in earlier versions but don't exist in that version. And like, is that good, bad? Can I just copy the old ones over? I don't know. That seems wrong, but weird. But you can learn a lot of things about software by making it build and work. Cool. Okay. So in the source, we're already looking at it. We can just go to the right back here. Cool. So now we're at the repo. And the other thing I think people, a lot of people, especially we think about doing, the latest commit in the Clang repos from 3 years ago. Yeah, that seems wrong. Although maybe there's a tag that is latest that I don't have yet, but I was using the Clang that ships with Xcode, the latest one. A lot of mistakes that people make is either just diving into the code and not reading the documentation that is right there in front of you because you don't want to do that, but you can learn a ton. There's already so much stuff in here. Although I will warn you, does documentation compile? What docs compile? There's one software I think that. Huh? Yeah, tech, I think. But it's more like a readable thing, and I don't know that the docs actually compile, but they're part of the source code. No newer branches. Oof. Thank you, JW01. So, yeah, the docs can be out of date, right? The fundamental thing of they don't compile means that like nobody's checking that it's actually maps to reality. So some of this stuff kind of maybe works. I don't know. It's like a good starting point. You have to read this like an archaeologist. Like at one point, people thought this. Like that may not be what reality is in this software, but at least I know that at a certain point, people thought this, and I can start from there. Yeah, so we're, okay. Like I think all this stuff about like building kernel caches and booting it, I think this is old stuff for older versions, but I would love to be proved wrong. Anyways, there's like a ton of stuff in here. What we are looking for is, I think right at the top that I missed. Okay. Yeah. So where is everything? So we got this giant directory, external headers, setup, BSD, config, doc, IOKit, blah, 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 blah. Where is anything, right? That's like one of the key things you need to understand as you start poking around things. This is kind of thinking of it as like, it'd be like going for a hike without having a map, right? You're just like kind of poking around, and you can get pretty far just grepping for things that you're interested in and reading code, but ultimately it's better to kind of know roughly, if I'm looking for this thing, where do I think it's going to be in this source code repository? So that's why you can look at this stuff. So config, configurations, this is where I think you can configure the version number, some tools that are used to set up. External headers are very important. These are used while building. We probably won't get into it, but IOKit is a C++ library to define drivers, and KX, I always say kernel extensions, but KX, I don't know if that's how somebody says that, but I guess you could do it either way. Kernel extensions. So as we will get to the point, hopefully, that you are popping kernel extensions. So this may be of understanding how to, but this should all be documented, so you probably don't need to look at this code necessarily. libsa bootstrap code for startup, that would be kind of interesting to look at if you're looking for like pre-boot vulnerabilities, jailbreaking kind of things. Libsyscall, this is super interesting. I don't think I've ever looked in here. This was maybe where you'd think where you'd go of like, this is where system calls go, but I think that's the opposite way. It's a library to be used for user space programs. So not fun. libkdd, parsing kernel data. I have no idea where this is used or what it is. Our good friend MSFNK, open source foundation mock kernel. So this is where everything, like this is where virtual memory management, task management, super important stuff is, that like this is a critical part of the kernel that we absolutely will need to know. pexpert, platform, interrupt handling, atomics. Maybe if we get curious about that, we can dig in there. Security, this seems kind of interesting. Like as a security person, this is something that I'd be like, boop, that's like somewhere I'd want to look. But like, I can't remember all of what's in here, but I think it's like checks of, like security checks, and there's ways to like specify like only binaries that are of a certain hash can get executed and things like this. There's all kinds of crazy checks, although I'm not sure if those happen in drivers or not. And then our good friend BSD. So then there's a directory in BSD that's the whole half of that BSD kernel. And then tools, which the interesting thing is here, there's the surprising thing in here is that there are test cases, like user space programs that use different system calls and stuff. So these can be actually a great source for understanding how do I write some C code that talks to this system call, because you have a test case that literally does that. And so you can yank code from there and actually use that code. So that's super useful. But you will probably spend most of your time in these two directories, the BSD side and the OSFMK side. Okay, so we've looked at this. We want to understand how system calls work. What do we do? What was that? Read source. So we let's click here. Find a C file. Ooh, there's a man page. Actually, this is interesting. Getting ahead of myself. I'm trying to remember where everything is, but console, I don't know, serial general. Now I'm reading code. Keyboard, starting a keyboard. I don't know, am I gonna find out where system calls go? Eventually, I will read all of the code in some order. Eventually, I will make it there. Is that an efficient way of operating? No? What was that? Is there a README? Ooh, what a good question. All right.
Search the code base for all READMEs.
Yeah, so first thing, we need to leverage the tools that we have available. I am not saying my workflow is the best possible workflow. I think you need to find a workflow that works for you. But what you need to be thinking about is how easy is it for me to find files of a certain type? Or how easy is it for me to grep, search through the source code of looking for a certain thing? I don't know if you load this up in like Visual Studio Code, if it will work and actually like have all the stuff. Also, because it doesn't know how to compile it, and you probably can't compile it on your own system, you don't get any of the nice language server features of jumping to definitions and stuff. So it's, I don't know if you've been able to tell, but I'm basically more old school in the sense that we'll start with this version 12.5, because I think that's going to be our target for the semester. I use either a combination of just the editor or the editor and like a terminal to like grep for things. So if I wanted to know, are there any READMEs? I would remember how to do it correctly. And then I would say, okay, there's a README in tools test, mppm test. And this is, I think, another thing of, the question is XNU open source? Yes, you can find everything at github.com/Apple OSS distribution/XNU. Yeah, good. Look at that question online. Awesome. So this is part of, I think, understanding things, being comfortable. You have to fundamentally be okay with not knowing everything. Like I look at this, I see, should I look up what the acronym MPMM is? No, because I don't care what it is. So I have absolutely no idea what this thing is testing, but I don't really care. But I've just seen this acronym. Maybe it'll come up later. Like it kind of lodges in your brain, but like, don't worry of like perf index. Is it testing the performance of the indexing engine, or is it, I don't care. I'm just trying to find out where the READMEs are to look for, are there any READMEs that are trying to get me to the system call stuff? Tools, LLDB macros. That sounds interesting because Adam did mention that they have great plugins and macros for LLDB. Those are actually in there. It is awesome. README-debug kernel. .txt. That could be interesting if we're like, how do we're supposed to do this. Wait, that can't be right. Is that a fake thing? Multiprocessor, multi-mushroom? That can't be. The multiprocessor, I believe. I don't know about the MM. libkdd readme. We could go back and look at the thing and be like, okay, what is libkdd? OSMFK tests readme, libkern zlib readme. So you're out of luck in your readmes. You've readme failed, I think. What was it? Oh, with an I name? Okay, so I name being case independent. No, because they're same people. They don't have readmes as undercase. Oh, you're just guessing. Okay, Macintosh page memory management. That could be. I'm responding to Twitch like a good streamer. So now what? We just quit? Google. We have everything here. The source is here. Is it? I read one command. Boom. Grep for syscall. Okay, now sorry, am I in front of a class? Yes, I'm in front of a class, but I can't show you because the class is stuff. No, you're fine. You're not distracting. We are streaming. This is what we do. Okay, so building up a grep can be a pain. So what do we want to do? Syscall -r star, so -r recursive, star everything in the current thing. I'm in the root here. I do this, and it's going to be all hell will break loose, right? Why is all hell breaking loose? Yeah, lots of files, but also lots of stuff I don't care about, like things in, for instance, all the things at the start. Do I care that build, dist, user, include, mock? We didn't see build in that list, but if we... Do I actually have a clean? That's interesting. Yeah, now it's not in there. But the build directory is where everything gets built when I do make. So it's saying like binary things match. Like, of course, like we're compiling a bunch of things and a bunch of object files and linking them together. Syscall will be absolutely all over the place. Okay, so I can grep for syscall. Cool. And so I deleted the build directory. You can also, there's ways, I can't remember it. Maybe I shouldn't just search for this. Isn't there a way to exclude a directory? Yeah, exclude dir. Okay, cool, so we can do that. Probably don't care about the tools directory either, or the tests. Like, I don't know, do I really care about that? Or tests. Look at this, I'm so much faster than Googling. Okay. So, now I have a bunch of stuff. So I have stuff in, because I'm looking at this here, just the left-hand side. I have stuff in BSD. I have stuff, oh, I may have gone too fast. I have stuff in security. So of these directories where we're looking at, based on what we just read from the README, which of these are more likely to have the thing that we're looking for? OSFMK, and what else? Yeah, I'd probably, can you do it like that? Yeah. So I'd probably look at those as a starting point, because those are kind of the core things. Now it could be, well, that's nice. So somebody has a much better approach. So here we have interesting things. So we have BSD. BSD apparently has its own conf directory, so maybe we'd want to look in there and see what, like if this is something we should be ignored. We have NFS syscalls.c there. let's see, skip syscall. Oh, well, this looks nice. BSD dev arm system calls.c. Should we look there? Yeah, that looks pretty good. Okay, because I'm not a monster, I'm going to use my editor. Now, how do I... No, I want to change the text. Sorry, I always have to look this up. Emacs change font size all frames. Globally, no. Changing font size. Current buffer, but I want all buffers. Change font size, all buffers. Control X, Control Plus. But that's what I do. All right, fine. For you all, I will do it. Okay. Okay, so we were looking at temp, building XNU, 12, wait, what? No, that's my own thing. That's funny. Okay, we're in here, we were in, and we saw a file in, what is it, BSD dev arm syscalls. Okay, so BS 12.5, XNU, BSD dev arm. Let's look at ARM64 because that's what we're using, and so if we're going to go to an architecture specific file, we might as well go to the one that, but maybe it's not here. Okay, so, but this seems interesting. Sys control int. Oh no, that's, anyways, we could dig in and look up this. This is like a key value store to like specify things that an admin can change, like, and root can change, like variables directly in the kernel. Anyways, this is, we could dig in and figure that out, but we're trying to dig in and figure out something else. Yeah, I'm in the wrong file because there is no system calls. So I'd go ARM64. I'm going to grep for syscalls in here. There's none in here. So, okay, let's briefly scan through systemcalls.c in ARM. Maybe it gives us something interesting. I'll just kind of vaguely, okay. I already see something interesting. Does anybody else see something interesting here? What was it? Syscall.h. Yeah, that seems interesting. Now we'd have to look up the exact compilation. I can't remember. I mean, having the angular brackets around this means like it's a library function that the compiler searches certain paths of figuring out where this file is. Whatever, I'm just gonna search for it. And I will fail. Oh, I actually do know why. Why is it failing? What? I'm in this directory. This is the kernel. We can't have external dependencies, otherwise we're... Say it again? I can't hear you. Yeah, so if a file, okay, so we know two things. We know this file has to exist for that thing to compile. I guess we've technically never seen this kernel compile, but we can switch to the version that does work, or I can port those changes over very quickly, and we can prove that this kernel does compile. But this file does not exist in the source.
Is it auto-generated?
It's auto. It must be, the compilation process must be auto-generated. And why can't we find it?
Because we have tried to generate it.
No, we did try to generate it, but then I cleaned it and deleted everything to make it easier. So let's rebuild it and see what happens. Okay. And it still won't work because it doesn't build. Awesome, awesome, awesome. What? Wait, sorry, what? Say it again? It has its own kernel headers in there. Yeah. So the problem was I was running make inside of the XNU thing, which is running their make, but I needed to go out one more to run mine that does everything that it needs to do. I really hope this is the reason. This will be silly if it's not. The computer's getting hot.
Is there something philosophical about a Mac creating another Mac?
I mean, you get into like the bootstrapping paradox problem, but fundamentally, no. Boom! There we go. See, and everything's in build, so this makes sense. So what this tells us is there must be some process that, like, as a pre-compilation step, and which kind of makes sense, right? Probably you want system calls defined maybe where they're necessary, and then collating them all from the whole kernel and creating one system call.h that everyone else can include. I don't know if it's actually done like that, but yeah, that's so. Let's look at. So now we do need that build file. So I was incorrect. So we need build. Let's go dist user include sys. Okay, cool. So we see sys call 0, exit, fork, read, write. These make sense because we know BSD is very similar to Linux. We know a lot of the Linux system calls. Link, unlink, we can just kind of scroll through these. Oh, interesting. Sys invalid, max syscall. Oh, so there's a macro so you can know the maximum syscall. Cool. And apparently some of these system calls you used to actually be able to call. You can read the book. The guy talks about these different things. But okay, so let's say we want to go to, there must be like a sys open. So, okay, we want to go to sys open, right? We know this macro.
You're excluding build.
I hoped it didn't, but.
You're also only looking at LSFP.
Might be a macro generator. Like
Yeah. Well, this may be too much, but I mean, I know this should be in BSD or not. What? Ah, what? Oh, interesting. Okay. That's going to take longer than I thought.
Also, I saw a telemetry syscall in there.
Telemetry?
Yeah. It's if you go and open the syscall.h. The standard telemetry syscall we all use all the time.
Okay, this is weird. Let's.
All your data belong to me.
Okay. So 451. Wow, random hashes. That doesn't seem fill me with confidence. Okay. Oh, there we go. Okay, so we got a hit, right? So at least the 451. So the intuition was if we search the 451 is not something that just like randomly occurs as you're coding. except in these hashes, right? So the intuition was, okay, if we look for that, maybe that will give us some clue, and we see something with telemetry. So we at least see, okay, there's this init sysent. And what's this in? Build obj. Okay, so this includes some stuff. The casts are bogus, but we'll do for now. I don't, what is that? Like, you know, who needs structs? Okay. Aha, okay, so this is cool. So now we get the 0, the 1, the exit, the fork, the read, the write, the open, and now we can maybe look at this as like syscall t star open, munge dub, syscall ret int t, ac open args 12. I have no idea what this is, but oh, what's this called? Requires, oh, interesting. So where does this open come from then? Okay, do we want to find telemetry? I feel like this will be way easier to find. Okay. See? I think what this is doing, without digging in, is that like, no, I don't know. I think it's because like it may need to work with 32 bits and require weird system call stuff. So the system calls are different on different things, and you need different like handlers. But yeah, you could definitely. Well, wait, so I highlight that. Yeah. Okay. So I had another trick that I've forgotten. Is it this? Ah, there we're looking somewhere. Okay, so I looked for just the telemetry we were interested in because we know that's some function. So the way I always think about this, right, is like this. If we have this .c file, this telemetry pointer, which is probably the exact function we want to call on this system call, is defined somewhere in here, right? Somebody is defining this thing, but I don't know exactly where. And I also don't necessarily want to go to the definition, because if I go to the definition, I also want to go to the actual implementation. I'm more interested in reading the implementation. So one trick is to do like look for something that looks like a function definition, or at least the call to the function. And so we see this nice, let's see. Yeah, I think that's the syscalls.master. Did we look for anything with the name of system calls in it?
I don't think so.
There's a kern/syscalls.master, which is not text.
Ooh, what was it?
Kern/syscalls.master.
But in BSD, you forgot to say BSD. Ah, and anybody see this? Make system calls. So our first thing was we didn't grep for just anything with any file with the name system call in it. That would have we would have definitely found that here. Yeah, so this is interesting. This is you could probably look over this of how they actually generate things. I don't care about it so much. Wait, that's not what I want. No, that's definitely not what I want. So then you can look for this of like their formats, how they create this. Yeah, so telemetry is a function that takes in a command, a deadline, an interval, a leeway, and maybe an arg4 on a 5. This no syscall stub though looks suspicious. So I don't know what that's gonna do, but seems to be not great. Oh, micro stack. Oh, I think I did look up this micro stack shot of like taking a shot of the stack of a process while it's running or something to like get telemetry debug information about what's going on. Okay, And we have this UIPC syscalls. Interesting. Okay, but where, so let's at least look at this telemetry and see if there's anything else interesting of like an actual implementation of that function. Okay, telemetry. I think that's us right there, right? Yeah, bit, kern. Ooh. Oh, this is the other trick I just remembered by looking at this. The other thing you can do in grepping for a function definition is, for whatever reason, this is like Apple's style for almost all of their things. So if you look for the thing you're interested in, like telemetry, parentheses, but add the start character, so it's at the start of the line, you'll often find the definition, and that is very helpful. And then we can see, so this takes in a proc pointer p, telemetry args, ret value, some return value. So at least just looking at this is very weird that these are both unused. Why would it not return anything? But so we could at least look at this and say, okay, args command, without even looking at the struct, we know, at least from the documentation that we saw of the system call interface, that the first argument was cmd command. Another interesting thing, there's an if def here. So depending on how our OS, how we may or may not compile this, but then we could also look at the kernel and have to find this telemetry function and maybe see if we even have telemetry. So there's these different commands, telemetry command timer event. This is when I see something like this that's very unique, I'll know that I can very easily find this header file. If we look at these header files, I don't know if, kern telemetry.h is where I'd guess, and that's going to be in, and I always have to find these. I think this is back in our object dist user include kern. No, try not to swear. Okay. Telemetry.h, osmfk kern. Wow, that's super annoying. This is the problem when you have these two, like I said, the two different worlds. Yeah, so this is like a BSD system call interface that's giving you access, it looks like, to the OSFMK kernel telemetry stuff. So what were we looking at? We were here, we looked at here. Sorry. There we go. Okay. So I just want to see where this thing is defined. There we go. So this is where things are defined. So we have these telemetry command timer event. Other question, is user space going to be able to access this header file? No, usually, so the idea is like you need from user space to be able to call this. So there must, like, these commands and these arguments have to be defined somewhere that user space can find them. And oftentimes it's like exactly these files. Yeah, it was kind of a trick-ish question, but anyways, the point is, because if we call a command to the kernel, we need to know what these arguments are going to be that we're passing in as command. And this, so there's an enum of telemetry PMI. Now this stuff I think gets yanked out. I think this is part of the compilation process when creating header files, this XNU kernel private, this stuff all gets redacted when it makes a public like kernel thing. But obviously since we're in the kernel, we need to see these files. Telemetry AST, that seems very interesting. I would guess there's bugs in here. Just from looking at this seems very complicated. Yeah, so telemetry timer event, and I bet there would be, since we're in kern, yeah, we're already in telemetry.h, there's a telemetry.c. So this is literally just taking the arguments from the args, the deadline, the interval, the leeway, which I think we saw in our syscall master. Deadline, interval, leeway.
Yeah, not only complicated, but maybe also under-executed.
Yeah, who's calling this stuff? The tricky thing, of course, to like, this is why you have to be very careful being like, I'm going to study this code and then find a bug and get rich. Then you find it and then you realize like, oh, actually there's a policy in place that like only root processes can talk to the syscall, which happens. So you have to be careful. You want to test it that you can actually call this from user space. This is why it's super important to verify your assumptions before diving in too much and being like, this code looks sus, as the kids say. Okay. Where was that C code we were looking at in BSD? Was that sysgeneric? Yeah. So that's the telemetry interface. Well, I think this is every system call. This is why it's unused. I think their system call interface basically always gets the current proc struct in there, and then passes the arguments as a pointer in the second arguments. So yeah, we can look at this telemetry timer event, a deadline, an interval, and a leeway, all of which are unused. That seems very weird. Why do you have code that has functions that get passed in that are never used? So if telemetry needs timer arming record or record is true, then set it to be false. Take some sample of the current thread and do this and then return 0. Interesting. What was that?
Oh, no, I see. Sorry. Yeah.
It's PMI setup, PMI counter, period, the interval. Yeah, another if def, so you got to be careful. Remember, like, again, the configuration thing. It's like every time you look at some configuration thing, you guys, before like getting excited that you found a bug, you need to double check and verify these things. This is interesting. Well, it's a const, but a character pointer. Those always are. Okay, so PMI CTR. So there's another command inside here, it looks like, that we can. This is coming from arg's deadline, which is then a switch statement on there, which tells me that there's some other functionality we can target through here. We need this sample all blah 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 MT. Oh yeah, it is this micro stack shot. Printf. The name. So it's setting up some name, and this seems weird. Can name come from us? No, it's either. Okay. Okay. So yeah, this is some micro stack shot thing. Interesting. Telemetry PMI unlock. That would be another thing to. Okay, so there's some mutex here. Yeah, I don't know. You always think like, could you mess with that? I mean, don't know. But anyways, okay, so we found a system call. We found like the entry point. We figured out how to get there. Did we learn anything about the kernel here?
It's sus.
All code is sus. Yeah. But now that we know this, and so like if we were doing this as a target, right, taking notes on this, I'd be like, oh great, syscalls.master has like the list of all the system call numbers and the functions, and then you'd probably say most of these UIPC, right? This was where, where was the telemetry? Sysgeneric. Yeah, sysgeneric was in where that telemetry is in BSD kern. So probably other things are in here, like ledger. Omnibus system call for ledger operations. See, this also seems sus. Like, why? Who's doing these ledger operations? But the double sus means to me that like that somebody else is, or that like it's just not used. So anyways, that's interesting. See, it's like if defs of debug. Like, so you think like you leave debug statements in your code, they leave if defs of debug structs definitions in their code, which probably are not. Interesting. So copy in, this is, we should, since we're digging in, we can look at this. I think we can already, where?
So like copy from user.
It's exactly like copy from user in Linux, but I do not recall the semantics. I think, yeah, so len is an int and size of len from args3. So what, arg3 must be a pointer to len. And I guess we can look at ledger and say like 1, 2, 3. Yeah, I can't remember what cadder_t stands for, what the C stands for, but it's like a user space pointer. And this is like the type they use to define that. Yeah, that's interesting. Yeah, we can look at, and we can maybe hopefully use my tricks if I wasn't full of. There we go. So now we can, I mean, we can go look at this, but at least we know the semantics here, the user address, the kernel address, and the number of bytes, copy.io.c. This would probably be something we look in our heads of like, I should like understand how this works. Also, so we don't do any copy if the number of bytes is 0. This copy validates function is very interesting because so you have to remember the security boundary here from user space and kernel space, right? So if we're copying something from user space, but the user has tricked us and given us a kernel address, and now we're copying kernel data somewhere, and that maybe makes it back to user space, that would be a clear vulnerability. So you have to be very careful when doing all this stuff. I assume this stuff's been tested, but I don't know. You're free to look at this and poke around here. Because like this copy validate, what's this do? What are these arguments? Whenever I see like flags to a function, this is like kind of makes me skeptical, and I'm like, what do these arguments mean? Can I grep for every single instance of copy validate and look to make sure that they're using the right arguments for that context? And can I do that quickly, just like manually? That's the way I would do this. Yeah, interesting. If the result is xdev, I have no idea what that means. Oh, maybe. Then copy in kernel, so it's a otherwise user enable access. Ooh, that sounds interesting. B copy in from the user address to the kernel address, and then user access disable. Now, I mean, we might as well look to see what this is. Ooh, ARM stuff. Great. What the heck does this do?
It disables privilege access temporarily.
Nice. So what is pan?
It's snapped for ARM.
Making sure that we can't access kernel stuff or user space stuff from the kernel. So so this is funny. Like this is just a thing that does nothing if this is not available on the system or the target. Privilege access never, I think. I thought you said network. I was like, that. I know that doesn't make sense, so I didn't go with it until I looked at it. Cool. So what?
It's just a function that you can call to toggle.
Yeah.
Well, it gets inline grouping. So like it's always like the disabled or enable access, and then it kind of should look like it's a
Maybe.
Now I looked at all of them.
You looked at all of them? Ah, damn. We could have found something right on stream. Okay. Maybe. Okay, yeah, so 0 means privileged region rights are not disabled. 1 means privileged region rights are, yeah, okay. Now this makes sense. So does everyone understand what this is doing? Well, now I feel like we need to just see if Justin is full of it or not. What is it, like -A for more context? I guess they're all in this file, so we could have just looked at them. I don't know. Could any of these fault?
Probably. But the problem is, at least on XCD6, the way that they do it, I think in the fault handler they re-enable when they reset the flags. Because I don't know. Well, I guess on ARM it's an MSR. So
yeah.
they just need to restore it to the previous state when they return from the interrupt or the fault.
Right. Yeah. That makes sense. Okay. Yeah. Here it's done very easy. Done very easy. Done. 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 That seems weird. B copy is like their raw copy. I don't fully understand what it actually.
For example, when you make on x86, it'll like trap certain instructions that used to be unprivileged. For copying in instructions to emulate. So
Interesting.
Instruction fault for invalid instruction, I try to copy it.
Question is, why do you need different ones? These are like almost identical in terms of like their semantics, from what I'm saying. Well, let's look at these B copies then, because if we're. I remember I looked at them before. I think they're just raw kernel, like just copy memory around, but you don't want people to use them. You want them to use the other thing. Yeah, and I think they're assembly. Ooh, look at this. See, look at you all learned assembly, and it's useful. There we go. Okay, OSFMK, ARM64. Machine routines, asm.s. All right, look at this. Okay. ARM64 stack prolog, push frame. I guess these are macros, I assume. Copy IO recover range. Move 0 into X4, the total bytes copied. The loop load a byte from the user source. So dereference X0, which is user address. Loader B. See, remember when I said they use all this crazy stuff, right? Wait, this is X0. Oh, this is a post increment operation, right? So it's dereference X0, move that byte into W5, and then add 1 to X0. So store a byte from user space, or load a byte from user space, store a byte to the destination. So then store, this is actually really nice. This is pretty compact, I like it. So then store W5, that byte to X1, and then increment that. So you have both of your pointers moving. Increment byte copied. So then X4 is what? 0, 1, 2, 3. Oh, X4 is always set to 0. That's going to be our return address. CBZ. If this byte is null, we're done. So compare. Oh. So this is like a copy until null. Is that the idea?
Copy and string.
This makes 1,000 times more sense. Okay, so yeah, so everyone get that? This is B copy in string, not instruction. Amazing. But see, we learned it by reading the code. This is what you have to do sometimes. But now I'm curious. Let's just like look at what the ending is. So compare x5 with null. If it's null, then branch to done, which loads, let's see what. Oh, store x4 into x3. So put the number of bytes read where x3 points, because x3, 0, 1, 2, 3 is the actual. So this is the number of bytes that we copied in. And then move x5 into x0, which was our, the result of the comparison, which if we're done is going to be 0. Right? Yeah, because that's the byte that we read in. Wow, that's a hyper optimization. But rather than setting, that is weird. Why not just set? You're right.
Because it's checking, did you hit a null byte or did you hit the size? Essentially.
Oh, okay. And then pop the frame and then epilogue. And then compare x4 to x2. And then branch back to loop. Otherwise, oh, the name was too long. Ah, that's interesting. So, okay, let's look back at our copy IO. In string, now that we know the semantics here, which makes sense why it's almost exactly identical except for that. Yeah, okay, so copy in and then results. Okay, so yeah, the vulnerability, I mean, this is like a classic stir n copy that doesn't put the null byte at the end of the string, right? So you can call that, and if stir n copy, you give it exactly the number of bytes, or it copies up to those number of bytes, and if it doesn't get to the null byte, it won't include it, and so you can have a null terminating string. So that's a similar problem that they have here, right? B copy in string. If you end up copying number of bytes, you will get this E name too long that gets returned as an error code from here. But then you need to be very careful that everyone that calls this actually checks the return value. So maybe we should check that. And I don't care about those ones. And let's give ourselves like 4 lines after of context, because that should be good. Okay, well that looks at an error. Oh, see, it actually tells us exactly what we just learned, right? E name too long is returned when length bytes haven't copied in, but the null pointer was not encountered. That does not require raising CPU dtrace bad adder and we press on. That seems weird. Okay. Okay, but this is in dtrace, and you need to be root to use dtrace anyways, but that could be something interesting. Maybe there's something there. Okay. Oh, there's this dtrace copy in string, which we probably don't care about. Yeah, so here's like, I don't know, null fs, is that literally like dev null? I think this actually may be the code that does dev null. Copy in, error. Yeah, this is something you could probably write a code QL query for. I'm just not very good at that. I just like looking at the code because the error checking is going to be the next thing that happens. So we see that there. See that there. If error, if not error, if error, return error. This seems weird, but it seems fine. That seems interesting. Copy in string. I don't know what this does, but it continues executing. That could be something interesting to look at for somebody in. So this is NFS, and just like on Linux, right? If you're creating some virtual file system, you have to handle all the virtual file system operations of open, close, whatever. Yeah, this seems sketchy. Maybe it's at the end of a loop, and then at the top of the loop, it'll check error, which we just don't have enough context to tell, but it seems weird. Yeah, we could do that, but I guess I didn't look at how many there are. Maybe I should have done that before looking at this, but we'll do this for like 1 more minute. That's an error check. That's good. That's an error check. That's good. That's an error check. That's good. And copy error. If copy error is not equal to 0. Okay. So this is the interesting one you need to look at, right? Because this is checking if copy error is named too long, and it only errors out there. But if it is named too long, then it also sets the last one to be null. So that's what we're trying to find. Error. Again, looks like another safe mark of a null byte. I gotta assume they would fix all of these, but you never know, and this is how you find stuff. Error check.
I guess maybe what you would do is write a code kill query that checks the like for the other like copy stuff that it's using the same like max pattern or something.
Yeah, where I could see this be an error, right, is if somebody used copy in and then just changed it to a copy in string without thinking about the semantics there, and then that causing a problem. Yeah, that's like, these are all fine. That's could be interesting depending on what this is, but I would assume maybe after all of these case statements that one of these is checking the error. But this is another interesting one at the end of something. Oh, here, maybe at this. I mean, I didn't think that we would find just a bug, a clear bug after this, but it was worth like looking at because I think it's a fun. Okay, this is hard to read. This looks like it's not checking. There's a debug and a resolver and then nothing. Maybe it's doing it afterwards. Kern credential sounds interesting. VFS lookup. I don't know. Anyways, okay, cool. So we practiced Recon, and now we learned a lot about XNU, hopefully. My intuition here is that there's probably not anything here. If there was, somebody would have already found it because these are very shallow bugs, right? The copying in from user space happens at the very first part of the system call. So testing this stuff is very, very easy. You just need to be able to talk to the system call. So it's not a bug I would expect like later on in the code, but hey, you know, whatever. Like if one of you finds some stuff with this, that's great. And that'll be good. Cool. Thanks for class.